Hi students, let's look at this question here, which is on integration, techniques of integration. Let's see how we can do this proficiently. So what you need to understand is we were told to find the derivative of x squared 1 minus. I think this is just a standard question here. So what you need to do is essentially just use quotient rule. So for this case here, d dx x squared 1 minus x squared, v squared 1 minus x squared, the entire thing square, v du dx minus u dv dx. Okay, just expand this. What we get is this will be 1 minus 2x cubed plus 2x cubed over 1 minus x squared and we were left with so this is 2x. So this is 2x 1 minus x squared. Okay, so from here what we need next is find the integral. So this integral here, just understand, usually say hence, right, very likely is by parts. So we already know from the first part we can integrate this, right? Okay, so from part 1 you know how to integrate this guy. Okay, this over here. So this guy over here, you know how to integrate it, right? So that's the idea. So from A, we know that we will get this, right? So to integrate this to x, 1 minus x squared ln x dx, we're just going to use by parts. This will be dv dx. This is our u. All right, then just write it down. So u is equal to ln x. du dx will just be 1 over x. dv dx will just be 2x 1 minus x squared. So v from the first part is x squared 1 minus x squared. Okay, then we're just going to uv, which is x squared ln x over 1 minus x squared minus of the integral of v du dx 1 over x squared 1 minus x squared dx. Okay, so this will be x squared ln x over 1 minus x squared minus of x over 1 minus x squared. So this you can use cancelling, or you want to use the school method, you can just put a negative half here and 1 over 2. Okay, so you can do that, or you can just side quest a bit. We can just the integral of x 1 minus x squared dx. The u is equals to 1 minus x squared. So this is the x u du minus 2x minus half 1 over u du minus half ln u. So this is what you get. Okay, I think the main thing is this. I can foresee that a lot of students will forget the negative. So this guy will give you a positive. Okay, just be mindful this is positive. This will be, there you go, done. So let's look at part B. Okay, what we need is to find this integral where you're in the first quadrant here. So we are told to find the polynomial. I think it's pretty okay. Firstly, understand the whole idea of substitution is to ensure that this guy becomes a function of theta, d theta here. Then you just need to change this, right? Everything changed to d theta. So basically this guy will be dx d theta will be cosine theta, right? Differentiate sine will just be cosine. Then after which, what we need is what do you call it? Make dx a subject. So we know that dx will just be cosine theta d theta. Okay, now then you substitute this dx into this guy here. Now, but I know a lot of students, you can just erase this, it's fine, don't worry about it. A lot of schools will not allow, but it's fine. Like I said, I keep saying, it's all in university textbooks. Okay, so square, just change this 1 minus sine square x sine theta, then dx is cosine theta d theta. Okay, great. So once done, understand that you get this as this is a very common trick here. Sine square theta, this will be cosine square theta, right? 1 minus cosine square, so cosine theta. So if you simplify everything, this will be 8 sine square theta cosine square theta d theta. Okay, so now you just need to change. This is not cancelling, so you need to change to any of the 8 expression, integratable expression. Okay, so here what I'm going to do is I'm going to change this to a common use what do you call it, the trigo ratio 2a equals to 2 sine a cosine a. So that will be sine 2 theta, right? So it's 8 sine 2 theta over 2 square d theta. Okay, be careful. I think this is where a lot of students will make a mistake. This basically what we want is this guy here. Okay, so it's divided by 2. Remember that. So this will be 8 sine square 2 theta 4 d theta. So this will be 2 sine square 2 theta. Then here we use double angle formula because we know that we can't integrate sine square, but we can integrate cosine theta, right? So cosine 2a is equals to 1 minus 2 sine square a. Okay, so sine square a, just be careful, 1 minus cosine 2a over 2. So this case here, what we get is a 2 1 minus cosine 4 theta divided by 2 d theta. Great. Then once this is done, we left with 1 cosine 4 theta d theta. Okay, be careful of the manipulation. I think the manipulation is quite sometimes it gets confusing. Okay, but once this is done, you know that this is just theta and minus sine 4 theta over 4 plus c. Okay, now we need to change back to this guy here. We change it back. So I'm gonna just put this as theta minus 2 sine, because now I only have got in terms of theta just a single angle, so I need to change. So x sine case, just is x equals to sine theta. Draw the triangle out, right? The right triangle here. We need to change it back to x. Okay. So this will be opposite over adjacent. So 1 minus x square root. Okay, so this case here, what we get is I need to change it to, so this basically I'm changing it to, so I'll show you. This guy would be sine 4 theta, just be double angle cosine 2 theta over 4 plus c. Then I'm going to double angle again. So this, I'm going to cancel this off too. They're left with theta minus 2 sine theta cosine theta. This is this one, after which this will be in sine theta, so 1 minus 2 cosines 2 sine square theta over 2. That's it. Then this is plus c. Then these 2 will cancel away. This is this, right? This is just a double angle. So this will just be 2 cosine theta. Theta will be theta from here. We know it's just sine inverse theta. So cosine theta here will just be 1 minus x squared sine theta just x, right? So we only have these two. So I'm going to just write this as theta equals to minus theta is sine inverse x, right? Minus of, you cancel this. Sine theta will be x. Cosine theta is 1 minus x squared theta 1 minus 2x squared. So this is our px. Px is what do we need? Px is 1 minus. Okay, so that's how I do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.